Here it is, a new 8-track machine for the 2020s. It's taken 2 years to develop. As the name suggests, you have 8 magnetic tracks recorded on a tape that's a little more wider than 6mm. Here you see how stereo is laid out, where you have 4 programs. On quadraphonic, you have 2 programs, where the tape speed is at 9.5 cm per second, which is twice the speed of cassette tapes. Here is an image of an 8-track cartridge showing how the tape loops back on itself. Here is your standard EQ curve shown in blue for 90 microseconds. In orange highlights the curve I actually ended up with within the design of the record EQ circuit. Here's the datasheet of one of the combo heads I was experimenting with. To give you some idea why the EQ curve ended up in the manner it did, just take a look at this section right here and you'll see that there's a 12 dB difference between the 10 kHz and the 1 kHz that needs to be taken into account. This image shows what a combo head looks like from the datasheet we just looked at. The layout of how the head works in the circuit. One side has the oscillator coupled into the arrays head, which you see here. Then that cross couples across to the record side, where the audio is fed back through via a trap from the record circuitry. As you'll notice, the labels are missing. That's still a work in progress. To help to maximise the recording time, I've actually put in a remain counter into the software, as you see I'm setting up at the moment. Once this is done, you need to select the input, analog or digital, and that's done here, as you can see. And we must not forget the all-important noise reduction, which is set up here, which is a combination of different types that can work together. There are 2 types of displays. You have your bar and your spectrum analyzer. With the digital inputs, the record levels are internally calibrated, so you just need to bring the dials right around, and it has an AND function where you've got to push the record and the pause button simultaneously. It also helps to be on the correct program you wish to record onto. We are now ready to record. Where the bar graph comes quite useful to check the levels. We want to be peaking at 0 dB and holding an average of -6, as you see here. Here is the record path. Come through the analog switch to the input stage, then to the expanded noise reduction block, then on to, in series with the B and C type noise reduction, down to the record amplifier, and that is fed across to the record EQ circuit. And then here it splits into 2 parts. One is the adaptive bias and the other goes on to the record head. The adaptive bias is somewhat different to HX Pro, where it uses a phasing technique, not a gating process. It is optimized to work with a combo head configuration, as you see here. We are now all set. Let's now try a test recording. Let's now look at the playback side. Here's your record playback switch going to the preamp, then into the play EQ circuit with the high and low trim, onto the B and C noise reduction, that is then fed onto the expanded noise reduction, allowing the expanded and the B and C noise reductions to work together to the audio output stage. This also drives the headphone amplifier and the meter drive circuitry that is fed back to the microcontroller for the display. Here is what the test recording sounds like on playback. You'll notice that there is some clicking in the background. That tends to be an issue between the sound capture device and the playback amplifier, so it's not actually there on the actual recording. Here is the control part of the circuitry where the user interface is connected in. We have our display driver that comes from the microcontroller, keypad input that goes back to the programmable logic controller, which is a cut down FPGA. Your tape counter, program counter are all processed within this logic block, just using a combination of logic gates instead of conventional mechanical switches which you would see in a more of a traditional design. That also drives the solenoid and the output for the bias oscillator. So we're using a 2x16 RGB LCD. It is possible to select from one of 7 different color types, or auto, which has been demonstrated here. This is the best it gets with 8-track technology. In green you see the Panasonic machine I tested with as a reference. Now if we look at the blue, this is what the output of the prototype looks like, just straight through without any noise reduction. And this is the improvements that are possible with the extended dynamic range with the noise reduction enabled. You up to 60 dB of performance. Now let's see what's possible for these different types of noise reduction systems. As you can hear, there's quite a big difference going on. Now let's take this recording we just made and put it back onto a standard player, and let's see how it sounds. Frequency components, but that's to be expected. I'm sure you're waiting to see what it looks like inside. Here's a look of what we've got. The main power supply, then we got the display board, the main board in the middle here, and a later addition which is the analog switch for the digital and the analog inputs. This is the area where the B-type and C-type dynamic noise reduction is located, and just above it you'll see the expanded phasing noise reduction. In the centre, this is the record EQ circuit with the adaptive bias, and up there is the meter driver circuitry. Down here is the bias filter, and if we look across to the other side here we have the microcontroller, then the programmable logic block, and this is all the control circuitry. There is a lot more I'd like to do with this technology, such as a need for new 8-track cartridge transports and mechanisms, because there's a very limited supply of donor mechanisms that are available from the 1970s, so we need something new if this product is going to go any further. I am also looking at ways of getting a new combo head design made for improved recording performance. Therefore I'm looking around to see who's able to do this. And the most important one of all, by far, is the importance of better magnetic tape formulations to be used with 8 tracks for improved high-end frequency response. Maybe a cobalt formulation that's able to work with standard bias. The working prototype you see in this video is version 3. I am also now looking at a version 4 design with all the improvements discovered from version 3 and possibly a future version 5.